Good afternoon, all of you. In today's session, we are going to discuss about electric potential. Now, in the last session, we have already spoken about electric potential energy, and today we are going to talk about electric potential. So, you remember that electric potential energy is for a pair of charges. So, suppose if there are two charges Q1, Q2 separated by a distance of r, then so if there are two charges Q1, Q2 separated by a distance of r, then Q1 into Q2 by 4 pi epsilon naught r is the electric potential energy, right? So Q1 into Q2 by 4 pi epsilon naught r, this is electric potential energy. Now, suppose this is Q1, this is Q2 and this distance is r. So if this is Q and if you replace this Q2 by 1 coulomb, and if you call this point as P, then V is equal to Q by 4 pi epsilon naught R is the potential at the point P. Okay? So Q1, Q2 by 4 pi epsilon naught R is electric potential energy for these two charges, and Q by 4 pi epsilon naught R is the potential at the point P. And to get that potential, we will have to imagine 1 coulomb charge kept at the point P, and then we can get the potential at the point P. So this is the topic: electric potential energy and potential. Okay, so this electric potential energy and electric potential, both of them can be defined physically. Like electric potential energy, we can say, is the work done in bringing these two charges from an infinite separation to a separation r. If you remember, when we were doing the derivation of electric potential energy, we had said that the two charges, they are initially at a separation of infinity, and later on the separation between them becomes r. So these two charges, initially the separation, just read forward. Initially the separation between these two charges is infinity, and later on the separation becomes r. So the work that is done to change the separation between them from infinity to r, that work done is called the potential energy of these two charges. Now suppose if you replace this Q2 with 1 coulomb and Q1 is Q, then that becomes the potential at the point P, right? So what is the definition of potential? It is the work done in bringing a unit positive charge from infinity to that point. So when you say potential energy, the definition of potential energy is for a pair of charges. But when you say potential, the definition of potential is for a particular point in space. So potential at the point P is the work done in bringing these two from infinity, is the work done in bringing 1 coulomb charge from infinity to the point. So potential is for a particular point, and potential energy is for a system of charges. Okay. Now the fact is that we can say like this also, that suppose there is an electric field and you have a charge Q, and you want to displace this charge in the direction of the electric field. So the force on this charge is QE. So you have a charge Q and you want to displace it in the electric field. So the force on the charge Q is QE. And for an infinitely small displacement dr, the work done by the electric force on this charge is QE dot dr. And you know electric force is a conservative force. So the negative of the work done is change in potential energy. So once again I am saying, when you have a electric field E and a charge Q is present in that electric field, so the force on this charge Q is QE, and the work done by the electric field on this charge is QE dot dr, and the negative of the work done will be the change in potential energy. But just now you have seen that if you change this charge q to a plus 1 coulomb charge, then potential energy becomes potential. So this is the formula, dV equal to minus E dot dr. This is the formula for change in potential, right? So change in potential as you are moving in an electric field is given by minus E dot dr. So that means the potential will decrease in the direction of the field. As you move in the direction of the field, the potential will decrease. Another thing is that if you remove the dot product, then it is coming to minus E dr cos theta. Suppose if you remove this dot product, then the formula is coming minus E dr cos theta. So this minus E dr cos theta, we understand that minus E dr cos theta will be 0 when theta is 0. Okay, minus E dr cos theta will be 0. It will be 0 when theta is 90, right? So if theta is 90, then dV will be 0. So minus E dr cos theta, if theta is 90, then dV will be 0. So that means that if you are moving perpendicular to the field, then the change in potential will be 0. So suppose you have a charge q and you draw a sphere of radius r centered on the charge q. So you know that the field will point like this. So perpendicular to the field means it will be along the surface, right? So the field will point like this and perpendicular to the field will be along the surface. So that means that the angle between the field and any movement on the surface, the angle will be 90. So that means on the surface there will be no change in potential. So this entire surface of the sphere is called an equipotential surface. So equipotential surface is a surface on which at every point the tangent is perpendicular to the field, and that means that on that surface all the points are at the same potential. So this is the topic for today, that is equipotential surface and potential. Okay, now there is a charge 20 microcoulomb, there is a charge minus 10 microcoulomb. Okay, there is a charge 20 microcoulomb, there is a charge minus 10 microcoulomb, and you have drawn the perpendicular bisector. You have drawn the perpendicular bisector to this line joining 20 microcoulomb and minus 10 microcoulomb. You have drawn the perpendicular bisector, and the distance from here to there is 6 centimeter, and on the perpendicular bisector at 4 centimeter you have to find the potential. So 20 and minus 10 microcoulomb you join them on the perpendicular bisector at a distance 4 centimeter. You have to find the potential. This is the first homework question. Number 2. Number 2, There is a charge q at a distance 0.3 meter from the charge. The potential is 1000 volt. So question is, what is the field? At a distance 0.3 meter from charge q, the potential is 1000 volt. Then question is that what is the field? Question number 3. There is a charge of 6 into 10 to the power minus 8 coulombs at the origin. So at the origin there is a charge of 6 into 10 to the power minus 8 coulomb. You want to take an electron from 3 centimeter to 6 centimeter. So there is an electron at 3 centimeter. You want to take it from 3 centimeter to 6 centimeter. So the question is, what is the work done? What is the work done by you in taking an electron from 3 centimeter to 6 centimeter? That is question number 3. And question number 4, there is two charges, 4 microcoulomb and minus 2 microcoulomb, separated by 1 meter. So in this line, at which point is the potential 0? So there is a charge 4 microcoulomb, there is a charge minus 2 microcoulomb, and distance between them is 1 meter. On this line, where is the potential 0? So these are the 4 homework questions, and you will have to submit it by 9 p.m. Thursday. I'll end the meeting. Bye all of you.